Good day everyone, I'm your Mr. ATL and welcome back to my channel. So today's video, we're going to discuss about relation. So a relation between two sets is a collection of ordered pairs containing one object from each set. In other words, if the object X is from the first set and the object Y is from the second set, then the objects are said to be related if the ordered pair XY is in the relation. Okay, so let us continue. There is a problem about or a story about Shan. Shan's story. Shan is working in a fast food store as a crew. He earns 50 pesos per hour. How much will be his earning after 6 hours? After 7 hours, and after 8 hours. Okay, so there's another story from Andrew. Andrew pays an amount of 25 pesos per hour for using the internet in a computer shop. How much will Andrew pay after using the internet for 2 hours, 3 hours, and 4 hours? So this is the Shan story. As you can see, if Shan will work for 1 hour, he will receive 50 pesos. After 2 hours, he will receive 100 pesos. After 3 hours, 150, and so on until 8 hours, that is 400 pesos. So therefore, after 6 hours, 300 pesos. His earning will be 350 pesos after 7 hours and 400 pesos after 8 hours. We can convert or we can represent the relation using ordered pairs, where 6 hours is for 300 pesos, 7 hours is for 350 pesos, and 8 hours for 400 pesos. It came from here, 6, 7, and 8 hours. Okay, so we can also represent the relation using table of values. As you can see, there is a table and there are values, no? So where the first column or first row are the number of hours worked, which are 6, 7, 8. You can also continue until 9, 10, 11, and so on, or on the other side 5, 4, 3, 2, 1, and so on. And then amount of earning for the next row, because after 6 hours, Shan will receive 300 pesos. After 7 hours, 350 pesos. And after 8 hours, 400 pesos. Okay, if you will compute for 9 hours, so just continue, that will be 450 pesos. Okay, once again, this is for the ordered pairs and the other one is for table of values. Okay, we can represent also the relation using this, where the first elements are the number of hours worked, the number 6, 7, and 8, and on the other elements are the amount of his earning. So after 6 hours, 300, after 7 hours, 350, and after 8 hours, 400. Okay, so as we can remember a while ago, we have an ordered pair of 6 and 300, 7 and 350, 8 and 400. So that's the same, but this is the other representation of that relation. Okay, so we can also represent the relation using equation or rule. So we have variable y, that stands for the amount of earning, and the variable x, that stands for the number of hours worked. So if we are going to substitute x, okay, as what I have said, x is the number of hours worked. Let's say Shan worked for 6 hours. So if x is 6, so you will multiply 6 by 50, and that will result by 300. Okay, so if x is 6, y is 300. If x is 7, 7 multiplied by 50 is 350. So that's why y will become 350. And if x is 8, 50 times 8 is 400. Okay, so this is the general rule or the equation to be used when dealing with the given problem. Okay, so let us go back to this representation. So as you can see, the first elements are the number of hours worked, and the second element is the amount of earning. So in here in the equation, x is the number of hours worked and y is the amount of earning. Okay, so that's the same with this with this representation, but they are different on how it is being represented. So this one is what we call the mapping diagram, and the other one is the equation or rule. So in the mapping diagram, the first elements are called the domain, and the second elements are called the co-domain. So later on, we are going to differentiate the difference between range and co-domain. Let's continue. So by the way, our 300, 350, and 400 are also part of the range. Okay, so using these numbers, we can also represent this relation. Okay, that is for ordered pairs, table of values. And for the ordered pairs, the first element stands for the x, and the second element stands for the y. That's the same with the table of values. This is the x, and this is the y. Okay, so this is the mapping diagram and the equation or rule. Once again, the codomain and the domain, which are part of the range also, the codomain. Next, let us represent the given relation using a graph. So this is for the x-axis and the y-axis. So I am going to put numbers here for the x-axis, and then for the y-axis also. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You can continue the numbers there to the right side because there is an arrow sign. That's it means that it can be extended indefinitely. On the other side, we are going to number it by 50, 100, 150, 200, 250, 300, 350, and 400. Why? Why didn't I number it as 1 to 9 or 1 to 10? Because as you can see, we don't have enough space for that. Okay? So you can extend on 450 and so on. Okay. So the first point will be located here because for after 6 hours, Sean will earn how much? Okay, that is 300. And then after 7 hours, after 8 hours. So as you can see, after 6 hours, 7 hours, and 8 hours, 6 is for 300, 7 is for 350, and 9 is for 400, and 8 is for 400. So the domain there are 6, 7, and 8 because these are the parts of the x-axis. Okay? For the range, we have 300, 350, and 400. So let us go to Andrew's story. So let me read again. Andrew pays an amount of 25 pesos per hour for using the internet in a computer shop. How much will Andrew pay after using the internet for 2 hours, 3 hours, and 4 hours? Okay, so These are the computation. After 1 hour, 25 pesos. After 2 hours, 50. 3 hours, 75. And 4, 100 pesos. So we can represent this relation using an ordered pair, where 2 is for 50, 3 is for 75, and 4 is for 100. Using table of values, the elements in X are on the first row and elements in Y are on the second row. Okay? Where the first elements are the number of hours used and the second elements is the amount of money to be paid. You can also convert, or should I say, you can also write the table of values vertically. Okay, so using the mapping diagram, 2 is for 50, 3 is for 75, and 4 is for 100. And using the equation or rule, y equals 25x. Let us check if this is correct. When x is 2, 25 times 2, 50. When x is 3, 25 times 3, 75. Correct. When x is 4, 25 times 4 is 100. Okay, meaning that's correct. Next, so the elements in X here is the number of hours used, and elements in Y is the amount to be paid. Okay, so once again, X is the number of hours used and Y is the amount to be paid. So this is the mapping diagram and equation or rule. So let us now represent the relation using a graph, where this is the x-axis and this is the y-axis, the vertical line. Okay? So let us put numbers here and on the y-axis also. So on the x-axis, we are going to number it as 1, 2, 3, 4 until 9. On the y-axis, we will start from 25, 50, 75, and so on. Okay, so let us now plot. The first one is 2 and the first ordered pair is the 2 and 50. So you can locate the points there. 2 and 50. 2 for x, 50 for y. The next point will be 3 and 75. The other one is 4 and 100. Okay, so let us identify the domain and range. The domain are the numbers corresponds to the x-axis. So what are those? We have 2, 3, and 4. For the range, those are the numbers corresponds to y-axis. Okay. So the domain will be 2, 3, and 4, and for the range, 50, 75, and 100. Okay, so let us remember that the first elements in the ordered pairs or the x values form the domain, and the second elements in the ordered pairs or the y values form the range. Remember that only the elements used by the relation constitute the range. So for me to explain this, let us have an illustration. So this mapping shows a relation from set A into set B. By the way, I have used the website mathisfun.com for this explanation. So as you can see, these are the domain 1, 3, 5, 7, 9, and these are the codomain. Okay, so we have 2, 3, 6, 5, 7, and 8, and we are going to find which are the range there. So this relation consists of the ordered pairs 1, 2, 1 is for 2, 3 and 2, 3 is for 2, 5 and 7, 5 is to 7, 9 and 8, 9 for 8. Okay. The domain is the set 1, 3, 5, 7, 9. That is the first element. 1, 3, 5, 7, 1, 3, 5, 9. The range is the set 2, 7, and 8. So the range 2, you're going to write it as 1. So do not write 2, 2, 7, 8 because 2 is being repeated already. So we have 2, 7, and 8. So that is the range. Notice that 3, 5, and 6 are not part of the range. These numbers 3, 6, and 5 are not part of the range, but part of codomain. The range is the dependent variable. Okay? So, let us go now to the evaluating the given function. Okay, so in here, when x is negative 3, just substitute x by negative 3. So that will be 3 times negative 3 is negative 9. 3 times negative 2 is negative 6. 3 times negative 1 is for negative 3, and so on. So negative 9, negative 6, negative 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So let us identify the domain and range. So the domain are the set of all values in x. So we have negative 3, negative 2, negative 1, and so on. And then for the range, so we have negative 9, negative 6, negative 3, 0, 3, 6, and 9. Let us now proceed to number 2, where the given function is f of x equals to 3 times x plus 2. So if we will substitute x by negative 3, so 3 times negative 3 is negative 9. Negative 9 plus 2 is negative 7. So that's why we have negative 7 there. If x is negative 2, that is 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. That is why we have negative 4. Okay, so if we have x is negative 1, 3 multiplied by negative 1 is negative 3. Now negative 3 plus 2 is negative 1. When x is 0, that is 3 times 0 is 0. 0 plus 2, 2. When x is 1, 3 times 1 is 3. 3 plus 2 is 5. When x is 2, 3 times 2 is 6. 6 plus 2 is 8. And when x is 3, 3 times 3 is 9 plus 2 is 11. So the domain will be negative. Okay, so let's start with the range. We have negative 7, negative 4, negative 1, positive 2, 5, 8, and 11. For the domain, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay?